Hey everyone, how are we doing today? Thanks for joining us here for this presentation that we're going to be doing. For the meeting itself, we're going to have the sound muted on your end. In other words, you guys won't be able to talk in, but you can write and type. And then at the end, we can field the questions if you guys should have any. We also have kind of a guest speaker. You'll see at the last slide. We'll let it be a surprise. But it's one of your colleagues that for one of the rep firms out of Phoenix, and he's going to talk a little bit about aftermarket strategies. For those of you that do a lot of it, great. If not, I think he'll have some great input for the long term. So we'll go ahead and kind of get rolling into this here, and then let me switch my setting here, and we'll get rolling. For those of you that don't know me, my name is Tom Cavazet. I've been with Lakos for 23 years now, and I really enjoyed the whole opportunity to be able to work with most of you that I do know that I could see on the list. And we'll get into the presentation, and today we're going to really focus on basin cleaning. So let's get started. So what are the sources of suspended solids? And for those of you that have the experience over the years, this presentation, we try to tailor it to kind of keep it pretty basic and to really target those that aren't familiar with filtration in cooling tower systems. So pardon me if I'm teaching you guys or we're going through things that you guys aren't already familiar with, but for those that aren't, hopefully this will inform you and kind of get you up to speed in terms of being able to talk to your customers out in the field. So what are the primary sources of airborne dirt and particulate? And it comes in through the air inlet faces of your cooling towers or condensers. In this case, the air comes in through the side. You can see the arrows pulling in, and the water washes it down into the basin. The other place is through makeup water. As that makeup water comes in, it could bring from the source itself, from the wells, if it happens to be sandy, or just pipe scale over the years that build up, can be brought in through your makeup water into the basins. And in specific areas throughout the country, they do have hard water. And as that hard water evaporates, you'll leave a lot of the precipitated minerality down in those basins also. So with the centrifugal separators, which I'm not going to get into a lot of details in terms of how they work, they do have to, the solids themselves need to be heavier than what the fluid is for a centrifugal separator to remove it. So the scale that drips or that deposits down into the basin itself can be removed along with the airborne dirt particulate. So the sources of suspended solids in a typical 200-ton cooling tower operating 1,000 hours can assimilate up to 600 pounds of dirt over that period of time. ASHRAE, in the handbook, it also talks about this particular solids loading, and 200 tons is fairly small in the big picture. So what we're tackling is that airborne dirt and debris that wants to accumulate in that basin. Where does the dirt go? Obviously, we talked about in the cooling tower basin itself, solids inside the condenser tube, the enhanced tubes, which are fairly popular these days with your chillers and the shell and tube heat exchangers. That dirt itself can accumulate in those enhanced tubes. And then at that point, all the extra surface area disappears because it's full of dirt and debris. And then also heat exchangers, the plate and frame style, they are very susceptible to plugging just because those plates and the galleries inside those plates are very small. So dirt will plug up those heat exchangers over a period of time too. Once that plugs up, then the heat transfer decreases and the efficiencies of those plate and frames decrease also. The bulk of where we see that, especially in the HVAC systems, would be with free cooling systems that are used in certain areas. ASHRAE states that a minimum of 5 ppm in terms of air quality and what gets entrained into the cooling tower on a 250-ton tower operating 2,000 hours can assimilate up to 5 inches of dirt in the bottom. If you go to 15 ppm, it can go up to 9.3 inches over a given period of time also. And that's operating a 4,000-ton tower, which is pretty good size at 8,000 hours, which is a very high operating time frame. This is a real picture. This was done, a cooling tower, a field-erected cooling tower overseas. that is close, obviously, to a very dirty and sandy environment. So if you're not able to go and filter that material, this is what the guys have to do out in the field. Nobody likes to do it, and it's not a fun process to do it all. I've been in a number of towers myself. What does the dirt do? So these next few slides we'll go through, and why do you want to get the dirt out of the system itself? The four primaries are corrosion, scale, fouling, and biological activity. So biological growth. As most of you probably know, filtration alone isn't the best way to treat a cooling tower. It certainly is better than nothing, but we can't control the algae buildup and all the biological growth that can take place. We can filter the heavy stuff out and remove the breeding grounds, but you still have the potential for the algae and growth. So we go hand in hand with water treatment. So you don't want to do just filtration on its own. Algae can be a very difficult thing to get rid of, especially in environments where the sun is hitting the surfaces and the water that's in the cooling tower. Scale is another one. This is the primary one that we're really targeting. In a lot of areas that have hard water, scale is one of the primary things that will end up plugging up the heat exchangers downstream, fouling up the fill, as you can see here, and really causing and wreaking havoc down in the basin itself. The picture on the right is a combination of your dirt and debris that gets caught up and collected in the scale. The scale is difficult to move. It won't move unless you have a piping system inside the basin itself, which we'll go through in a little bit. So what happens is you get that scale that breaks off the fill, or as you're precipitating that water, it will be left behind in the basin itself. Corrosion is another issue that if you can't get in there to clean out the basins, you'll end up seeing what happens when you drain a tower and the basins are left with improper filtration or no filtration and improper treatment of the cooling tower surfaces themselves. So what you want to do is make sure that we get that dirt and debris out so it doesn't just sit stagnant inside that cooling tower and rot out the basins. You know, on average, basins lasting in between 5 to 15 years, and I've seen some, even stainless basins, which is the picture on the left, corrode in less than 5 years with very poor water treatment and no filtration at all. So just because you have stainless basins doesn't mean that you shouldn't filter or obviously treat your water regularly. So how does corrosion occur? If you allow those solids to build up in the basin itself, you get the solids, when they build up, you get the sulfate reducing bacteria, which is the SRBs. It multiplies. The SRBs reduce to sulfates and turn it into hydrogen sulfide and result in the metal surface pitting. So, and the Center for Disease Control says all it takes is a 1/16 of an inch of buildup in that basin to act as a barrier. So your corrosion inhibitors or your biocides that are there to treat the basins or to treat the water, this will act as a barrier and they cannot get to that metal surface. So you allow the bugs and the corrosion to occur even though you are treating your water. So fouling is another big one. We all know that energy is not cheap in a lot of areas, especially here in California. We could pay up to anywhere from 10 to 13 to 18 cents a kilowatt hour. And the shell and tube heat exchangers are not as susceptible as the plate and frame heat exchangers, but they still will foul over time. And so what happens is that dirt and debris builds up inside these basins. The overall efficiency of your system, let's say it started out at 70 or 75%, can foul over time, and maybe you're operating at 50%. Well, if you're operating at 50%, that means your pumps, your motors, your compressors, all that equipment that requires a lot of energy to run has to work that much harder or possibly longer to maintain temperatures. So for example, if you are running a system at 2,500 hours a year and you're paying 13 cents a kilowatt hour to run a chiller, let's say it's 500 to 1,000 tons. That cost can be anywhere between $75,000 to $150,000 a year. By maintaining that chiller or making sure it doesn't look like the picture on the right hand here, it could, if you put your filtration in and do your water treatment properly, you end up saving, let's say, 10%. That $17,000 or $10,000 or $8,000 that you end up saving from just energy costs could pay for that filtration skid to be installed on the cooling tower basins, which we'll get to in the next couple slides. So energy is one that a lot of people don't necessarily think about, and they focus more on the maintenance side of it. But energy can be a very big expense in operating a building and the cooling system running throughout the building. As we discussed plate and frames, this is a great picture of plate and frame heat exchangers that are used on open towers. I've seen them plug up in a matter of hours and minutes at times. In Denver, they have a central plant, and a lot of the buildings downtown would purchase chilled water from the central plant. They would rip out the old chillers in the buildings, put in plate and frame heat exchangers, and all the pipe scale of 30 plus years that build up inside these pipes gets broken away, and the plate and frame now becomes your filtration skid. So you don't want to do that. Plate and frames are very expensive to tear down, re-gasket, and you have to acid wash plates and then put everything back together. And they're down at that period of time too that they're having to do this. So plate and frames are very susceptible to the plugging, and you're not able to maintain the cooling throughout the system, obviously, when something's down or plugged. So what are some of the other problems with suspended solids that we allow to stay in our basins? Number one is confined space and downtime. The picture that you see here, if I were to obviously allow everybody to talk, I ask the question is, what do you see in this picture that probably isn't the best practice? The most often people mention first is you have a metal-to-metal surface. You have a metal shovel scraping on a galvanized surface. Over time, if the galvanized was scraped off, all of a sudden now you're going to see rust spots over the years because you have no more protection of the carbon steel metal. Second is that trash can in the left-hand side. That trash can will fill up with dirt. How do you get it in and out? It's got to be extremely heavy with wet dirt inside of it. Third, he's got boots on a slippery surface. There's obviously hazards of falling, slipping, and getting hurt, which obviously nobody wants that to happen either. So it's not a great experience to have to be in these cleaning them out. Increased maintenance costs, which is the one that people focus on probably the most. In this case, you can see somebody with a vacuum literally sucking all the material out of the basins, and it's difficult to get all of it. So you do have residual stuff that's in those basins, and you have to do it fairly frequently. It doesn't take very long for a basin to accumulate the solids. And Legionella concerns, the more dirt you allow in your basin to stay stagnant, and if the water treatment can't get to it or the biocides, then you have the concerns of bacterial and biological growth. There was an outbreak at Disneyland that some of you may be aware of. They kept it pretty quiet, but there were a couple people that contracted Legionella over a contaminated tower, and obviously lawsuits are going to ensue. So it's important to maintain the basins as much as you can. So how do you counter suspended solids? Filtration applications specifically, you can do full stream. Basin cleaning, which is the one we're going to focus on in the next few slides, and side stream. Full stream is 100% of the flow, basin cleaning sized on square footage, and side streams typically anywhere between 5 to 25% of your condenser water flow. So for basin cleaning, one of the nice things about doing this is that you can actually order from the three major manufacturers, I'll say, Evapco, Baltimore Coil, and Marley. You can order a Lakos design sweeper piping to go inside those basins. We've worked directly with all three manufacturers. The key is just to make sure that when you order it from the factory, that whatever filtration skid, which you can see here, is matched to the flow rate that they're requiring inside the basin itself. You don't want to go too large, and you certainly don't want to go too small because it will not operate properly within this basin. The other advantage is we're independent on the basin of anything else going on within the system. So we don't have to tie in to the actual condenser water loop. In this case, we just tap a hole in the bottom of the basin, run it through the skid, and we put it right back into the PVC headers that are down in the basins themselves. So here's just a rough picture showing, this would be more kind of similar to an Evapco style or a Evapco AT or a BAC 1500 series. With Marley, I know that they have 2 upper decks in the center section on most of what I'm familiar with their NC series. But I think some of their smaller units do have an upper deck and lower basin like you see here too. So all 3 manufacturers have a similar style to this. We want gravity to be our friend. So you would want the piping to blow down off the top surfaces, down into the lower surfaces. And you always want to try and direct the solids away from where your condenser water pump is pulling from those basins. So you go down, down, and then back to the filter suction away from your main outlet. If you guys remember anything from this presentation in terms of sizing, if you look here, this is our little logo, and it's on a lot of our literature and a lot of the sizing details within the O&Ms and stuff. It's 1 gallon a minute of filter pump flow rate for every square foot of your basin area. So if you have, for you mathematicians out there, if you have a 20 by 10 basin, I'm going to assume you guys figured 200 square feet. So in that case, you would end up applying about a 200 GPM filtration skid to that particular basin. And like I said before, you need to make sure that whatever piping, if you're ordering it from the factory, Marley, BAC, or Evapco, just make sure again that the piping flow rate requirement matches the filtration skid that you're applying to it. Basin cleaning benefits, which we kind of went through some of those already, but you can see an actual installation. It's fairly straightforward. It's PVC piping, extensions, and then our hydro booster nozzles. For those of you that are aware of those, we have the blue ones that go with our older, I'll call it, style TC packages, and then the yellow ones, which are the newer ETCX series packages. So you want to make sure also that we're applying the right hydro booster nozzle to the filtration skid that you guys have selected. So again, the benefits: reduce fouling in the condenser, you can remove solids at the source, maintain cooling tower approach temps, which is a big one. Again, that kind of goes back to what we talked about with energy. Reduce maintenance and downtime, and then again, the sizing. If you guys write anything down, it's 1 GPM of filter pump flow rate for every square foot of your basin. So you can get in there and actually size something fairly quickly without having all the details if you just remember that little simple formula. Just some basic layout pictures. So best practices, you want to make sure you get as much coverage as you can with the actual sweeper system, which that's all the PVC piping and nozzles. We want to make sure that there's nozzles at the air inlet faces. This is a plan view of a typical like NC type Marley tower or a 3000 series BAC basin. You want to make sure there's nozzles in the corners to sweep back at those air inlet faces, and we push the dirt towards the center. And then as the flow from the other nozzles wants to draw the water underneath the fill, that pushes it in towards the basin. Again, we're going from a high area to a low area. And then we direct all that dirt and solids right to our filter pump suction. One thing I will point out with this, if we're going to sweep multiple cells with a single package, we need to make sure that the cells are actually equalized. If not, it's extremely difficult to get the exact flow to each cell, and you could potentially drain one and overflow another. So if you're going to do multiple cells with one unit, make sure they are equalized. I see that you guys are raising hands, and we'll get to those at the end. So in this case, the filtration skid would sit out here. We have a header, a common header to tie the 2 cells into the filter, and then the skid would sit here, and then the discharge of that separator with the clean liquid just runs back to the sweeper piping down in the basins. So we kind of call this a budget practice. I have a lot of reps that are actually doing this particular practice. It's worked extremely well. We will provide it up to 4 cells. So let's say in this example, we have 1, 2 cells. and we have one filtration skid. What we're doing is we're alternating between the two cells. We'll start with this one. Let's say we run it for 8 hours a day. The PLC tells it to switch, and then we'll switch to this cell after 8 hours. And then you go back and forth. Maybe it's only 4 hours. Maybe it's only 3 hours. It just really depends. But what this does is you cut your filtration skid down. Instead of having to size it for 2 basins, now you could size it for 1 basin, which cuts down your horsepower in half. The system's smaller, and we actually have a really nice design package system with the valves and actuators that tie to a PLC that can control all this out in the field. It's easy to program. You're not having to run a big pump. Let's say, for example, we had 4 cells and each of them required 300 GPM. That's a 1,200 gallon a minute system versus one 300 gallon a minute system. So it's very practical, and especially if you're working with engineers that are energy conscious, which most of them are, it's a good solution to be able to apply to these towers as long as you're not in an extremely aggressive, dirty area. If that's the case, we probably want to put 1 package per cell or have 1 package do all of them at the same time. So to kind of recap some here, we're trying to keep this to about a half hour. So to recap some of the benefits of filtration. You maintain design efficiencies on the condenser and the cooling tower loops, resulting in energy savings. You get the extended equipment life cycle. So if you're maintaining your equipment better, just like you would your vehicle by changing the oil, you get the extended life of that equipment. You can reduce maintenance and shutdown, resulting in productivity if you're applying filtration to these skids in manufacturing environments. If they can't maintain temperatures on your equipment that's doing all the process, they shut down, and certainly once you shut down, if you're not producing product, that's an extreme expense or cost to the company. All right, so let's see if we can do this. This is our guest speaker, Greg Johnson, and actually he's representing Lakos here, as you can see. That was taken by me at Pebble Beach. So he ended up selling quite a bit of equipment when we introduced our E-Series packages, and he won a nice little trip out of it. So let me see if I can get Greg online here. Greg, can you hear me?
Hey, Tom, can you hear me?
Yep, I can hear you, Greg. Thank you.
Okay.
So, all right, let me, so as I said kind of at the beginning, Greg has done really, really well over the years with aftermarket filtration. And so I wanted him to kind of give a little insight in what they do and how they do it and how they've become so successful. So, all right, Greg, the floor is all yours.
Thanks, Tom. Thanks, Lakos, for kind of staying open through our current issues we got going on. We're going to come roaring back in another month or so here, so everybody be ready. When we think of Lakos and the retrofit market or the replacement market, there's a good amount of aging applications out there, and just time for the picking. These are going to be applications where you're working directly with the owner, so you don't have middlemen, you know, playing with your game. The replacement market can be fairly easy. You see a lot of sand filters out there that have gone to the wayside or turned into a rock well before their time. The TC package is just a great replacement for it. The only thing I warn you about is, you know, watch your horsepowers. Electrical will be the most expensive part of the installation, so that's one area that you need to focus on. The Lakos systems have such powerful pumps. Don't be afraid to match horsepower and maybe, you know, look at your pump curve, overstate your flow a little bit to get the customer taken care of, but keeping the installation costs down. Get to know what's bugging your customer. Some customers may have issues with fouling in their tubes, which could be more of a full stream application to give them the best result there. Or it's cleaning the mud out of the bottom of the tower. You can pretty much guarantee he's not going to ever have to get in there with a shovel again. The next thing would be utilize the Lakos engineering department for your sweeper piping designs. They can kick them out pretty quick for you, and they always work. Is one thing I've always seen is you don't have a bad sweeper application if you use the Lakos design. Retrofit, again, it's going to come down to the owner and where he wants to spend his money. Factories and hotels and schools can be an easier proposition for them because you can, by the time you add electrical, a Lakos, and the piping can be a fairly expensive proposition. And as Tom mentioned, utilize the valve packages and put in a system size for one tower and sweep multiple towers. We don't need to be sweeping 24 hours a day to have a pristine basin. We can get away with a third of that or even less possibly. But your regional managers are your source. They know what we're selling. They know they can help you push you into the full stream sand filter or tower clean package direction. One last item is we have seen that the cleaning efficiency of the new E-Series separators is just really superior to the TC package. So don't be afraid to try and get that extra little bit of money that those cost and, put more in your pocket, but just provide, just that little bit extra efficiency that can make a big difference in the end. You guys can always call me if you want any advice, but I'd use my regional manager actually. But no, thanks for letting me talk. Man, everybody stay safe out there. We're privileged to still be able to be working and get ready for a big onslaught of orders here after we get this behind us. Thanks.
Awesome. Thanks, Greg. I appreciate it. And for those of you that want to ask questions, on the bottom of your screen, you can see the little, the icons, for lack of better terms. You're welcome to type them in. We're going to keep everybody muted because it would be kind of a mutiny trying to get everybody at one time. So if you want, you can go ahead and start typing, and I'll try and review them as quick as I can and give some answers as I can. So if you have any questions, go ahead and type them. Okay, the question is, recently we discussed, and this is from, if you don't mind, I will say the name. It's from Eric Bling in Southern California. He's my rep in San Diego. We recently discussed backnet connectivity. Can you explain what the benefit gives us? So that benefit itself, we only offer it on the E-Series packages, and it's because of the type of panel that we're actually using in there. It's that smart panel, and the module for the backnet can be plugged in. And what that does is it gives them multiple points to monitor regularly, whether it's amperage, whether it's sending signals back and forth, whether it's power, and it can communicate directly with their actual building management system. Otherwise, without the backnet, you can monitor through dry contacts, maybe 2 or 3 points, like the motor start and stop, motor status, your amperage, and then I think voltage is the other one. So having the backnet in there gives that capability of being able to monitor up to, I think, probably 15 different things within that control panel that you can. All right, thanks for the question, Eric. Hopefully that answered it for you. And then we've got another one. We've got a couple here. I'll just go down the line as they keep coming in. So the second one is from Matt Atkins. And Matt is the rep up in Seattle. He's been dealing with Lakos for a number of years. Him and I have been working together for 20 years. So Matt, thanks for the question. And it says, in what ways is the source water used for purging debris or use of recovery vessel more popular? I would say that it's a 50-50. It really goes geographically, at least in my territory. The recovery vessel, you have maintenance. And so if you know that it's on a building where maintenance is going to be an issue, where guys aren't going to maintain it, I would probably lean towards doing the auto purge valve versus the recovery vessel. The bags act as kind of a secondary filter. You can size them for 25 microns or 50 microns, or we can even go finer if you want to, but they will plug up quicker. The purge valve itself, that in its own, if you're dumping water, it kind of goes in conjunction with the water you'd blow down anyway. But the perception is that you continuously dump water, and that's not the case. We might lose maybe 20 to 40 gallons of water once a day if that's actually purged. So if they know that there's going to be maintenance issues or the guys aren't going to maintain bags, I would automatically go and use the the ABV or the auto blowdown valve versus the bags. Does that answer your question, Matt? All right, no response. I'm going to take it that we got it answered. All right, second, Olivier Guardado. Sorry if I mispronounced that. His question is, I don't know Olivier or Oliver, but his question is multi-tower cleaning kit and alternate tower with a timer and not with a PLC. Good question. The multi-tower kit, we can go up to 4 cells. It is controlled with a PLC, which is kind of, it has a built-in clock in it. So if you don't use the PLC, we're not going to provide a controller that has just a timer on it. You can program the PLC to tell it when to kick on, when to kick off, how many hours to run, and what towers to run and cycle through. Maybe you have one that's down that doesn't have water in it. Maybe they're servicing it for whatever reason. We can zero out that zone, so as it alternates through, let's say, a 3-cell, it will only alternate between 2 cells. So hopefully that answered your question. So we, as a factory, will provide a PLC to do the controlling. If you choose not to use our controller, then you guys can set up whatever you would like, but we would prefer, obviously, to have the PLC control it. So hopefully that answered your question, Oliver. Next is Kevin Lynch, which Kevin is rep out of Southern California. Thanks, Kevin, for listening in. He works with the vertical systems guys. And his question is, if you have a single TCI serving multiple closed circuit fluid coolers, do you need to equalize those coolers too? The answer would be yes. So cooling towers and closed circuit coolers, obviously most of you know the difference. One has a lot of fill in it and there's no coil in it. And the other one has the coil that you just recirculate water over the coil. But the basins act as the same way. That I've actually seen multiple installations, and one of them is actually down in your area where they didn't equalize them, and we are overflowing one to the other. So equalizers are still required if you're using closed circuit coolers versus open cooling towers. All right. Hopefully that answered your question, Kevin. So move on, and Greg jumped back in here again. He says, I forgot most important. On open loops, always use ABV. Bags can be a hassle. Maintenance men don't like the hassles. Which I would agree with Greg. Again, kind of goes back to what I mentioned. If you know that maintenance isn't going to be performed, always offer the ABV. It will save a whole lot of headaches in the down run, or in the long run. All right. Any other questions? I'll give a few seconds here if anybody has anything else they'd like to ask. All right. Well, then with that, we'll go ahead and call this a wrap, and we appreciate everybody's time joining us today. Please stay safe out there, and as Greg mentioned too, that we're all looking forward to getting back out there, and I won't say getting back to business as usual, but we're going to get out there and hustle it up and make sure we're providing a great solution to everybody's needs and problems. So you guys have a good afternoon, and hopefully you'll contact the regional manager with any Lakos questions or concerns, and we'll make sure to get you the answers as quick as we can. Have a good afternoon.